All right, awesome. Welcome back to Math 160. So we started looking at our chapter 7, which was linear regression, that correlation, the causation ideas. We're kind of looking at all this stuff together. Last class, we actually calculated the Pearson correlation coefficient together with this crazy formula. While this is, it's cool to be able to see, at least once. We are not going to calculate this by hand. No worries, Lainey. Thank you for letting me know. We are not going to calculate this by hand in class ever again. This is the last time we do it. We just want to share exactly the process behind it so you can see how sophisticated the computation really actually is. It also helps to kind of think about how the correlation coefficient is even derived. Like the fact that you have to work with each of the ordered pairs, and then you have to either sum the individual columns of the X variable and the Y variable. Sometimes you have to square them. Sometimes you have to multiply the X and the Y coordinates together. It's pretty crazy. It's very, very sophisticated. So it's a nice way to introduce you to the behind the scenes stuff. But we're only going to do this once, and there it is. So we calculated our coefficient as 0.61, and according to our table, we were able to confidently say this is a positive moderate linear correlation. So let's turn the page, and I'm going to introduce you to the idea of determining whether or not the R value indicates a linear correlation, right? So this is really important to note. Like we have to decide, is it actually indicating a linear correlation? So in the previous example, we looked at n is equal to 5, and we found the linear correlation to be 0.61. However, is this actually strong enough to indicate that there is in fact a linear relationship? So that's when we use something like this table. So this table represents the critical values of the Pearson correlation coefficient R. So I'm going to go ahead and highlight this. You definitely want to make sure that you have this page handy. I do have a set of tables all grouped together, and I want to double check that that's on Lumen. But make sure you put like stars next to this as a reminder that your table is here on page 8 of your notes. Now it states, if the absolute value of R, right, if your correlation coefficient, whether it be negative or positive, the absolute value will result in a positive value. If that is greater than the value given in the table, so let's write this down. If your absolute value of R is greater than the table value, then you can conclude at the 0.05 significance level, which indicates you're 95% confident that there is a significant linear correlation. So if this value is greater than the table, there is a significance, it helps to write it out, linear correlation. Okay, that's what we have to keep in mind. If the absolute value of your correlation coefficient is greater than the table value, there is a significant linear correlation. With our previous example, we found that when n was equal to 5, our R value was 0.61. You remember that? Like, let's take a look really quickly again. We found that our R value was 0.61. This is when n was 5. So what we're going to do is we're going to look at the table, and we're going to focus on the row where n is 5. Notice that the R value is 0.878. So we're going to note we had an R value of 0.61. This is the one we calculated. The table value was 0.878. Luckily, we cannot say, I shouldn't say luckily, in this case, we cannot say that 0.61 is greater than 0.878. This is a false statement. So I'm going to draw a slash through that, and I'm going to say this indicates that for our previous problem, there appears how should I say this? To be a how should I say this? Help me, my brain's not working today. I want to say it's not a linear relationship.
No significant linear correlation.
Thank you. That is so good. I was missing that B. My brain wasn't working. There appears to be no significant linear correlation. Oh man, that was said so good. Thank you so much, Kelly, for bailing me out. That's what happens. No coffee. I know I should be drinking some, but
how do you function without coffee is the
I
question.
don't know. Clearly, I'm not functioning well. Clearly, it's not well.
I'm on pot too, so.
And I have to like Grubhub you some coffee. So
I know.
Coffee is what I'm hearing.
The funny, it's literally in the other room. Like I should just make a cup. That's okay. That's okay. I'll just wait. You guys can help me. You all help me. This is great. Perfect. That's it. So you just verify. You check your calculated correlation coefficient. You compare it to the table. If it's greater, cool. It's significant linear correlation. If it's not, oops, nope. It's not a significant linear correlation. So let's try a few practice problems just to make sure we're understanding this. Keep this table out. You're going to obviously need it for the next few examples. Number 8, given these specific conditions, determine if the evidence is strong enough to indicate that there is a linear relationship. We have calculated that our R value is negative 0.51. So again, we still have this idea that we want to check to see if the R value is greater than the table value. Our R value, absolute value of negative 0.51, that is the same as a positive 0.51. And we want to determine if it's greater than the table value where N is 12. Angelica, what is the critical value when N is 12 according to our table?
0.576.
Perfect. We look at the table, we find that it's 0.576 when N is 12. Notice that 0.51 is definitely not greater than 0.576. So we're going to say there appears to be no significant linear correlation, relationship. We can write relationship just to use the terminology from the question. Good, done. That's pretty much it. Let's do the second one. We have an R value of 0.73. We want to determine if that's greater than the table value when N is 7. And Sam, what is the table value when N is 7?
It's 0.754.
Perfect. Notice that this is not a true statement, so you can literally duplicate exactly what we said. So there appears to be no significant linear relationship. Good. Do part C on your own and then write the associated statement, and I will double check. Lucy, you want to verify that the value you calculated is greater than the table value. So for instance, with this one, when N equals 12, we saw that our table value when N is 12 was 0.576. So we compared that R value, right, the absolute value of that R value with the table value. Since it's not greater, there is no significant linear relationship. Same thing with part B. When N was 7, you go back to the table and you see that your R value is 0.754. So we compare the value we calculated with the critical value from the table. We see it's not greater, so there's no significant linear relationship. Good, awesome. So we're gonna do that again. Check with part C. You're given an R value of 0.62. You know that your sample size is 23. And you want to determine if it's strong enough to indicate that there is in fact a linear relationship. Mike, thank you so much. Exactly. So then you can make a statement associated with what you found. In the chat, you can go ahead and send a private message to me. Is there a significant, does it appear to show a significant linear relationship or not? So in the chat, go ahead and let me know. Thank you, Carrie. Thank you, Mike. Leah, Holly, thank you. Thank you, Lainey. Thank you, Lucy. Remember, check the R value you have with the R value from the table. Thank you, Kelly. Thank you, Nick. Thank you, Anthony. We'll do 2 more answers in the chat. 2 more answers in the chat. Thank you, Abby. Excellent. 1 more. Awesome. Thank you, Jenny. Yes. Okay, let's check it out. So the R value we were given, I'm going to write this out again because maybe it'll be super helpful if you kind of see this language again and again. The absolute value of 0.62 is still 0.62, right? It's the positive distance from the number to 0. That's what happens when you take the absolute value of a number. We're going to go to the table when n is 23. When n is 23, we find the table value of 0.413. So I'm going to fill this spot in with 0.413. Notice that 0.62 is in fact greater than 0.413. So there appears to be a significant linear relationship. So yes. Okay. A and B, there were both no, because of the fact that our correlation coefficient was not greater than the table value. For part C, our correlation coefficient was greater than the table value. That's okay. That's okay, Lainey, no worries. Perfect. Excellent, Sam. Thank you so much. So there's a note here at the bottom. The size of your sample matters. A linear correlation coefficient of 0.85 is considered a strong linear relationship. However, notice if you had a sample size of 4 or 5. So look at this Pearson correlation, 0.85. This is what we calculated. And technically it would be considered a strong linear relationship, right? However, look at the table. If we had a sample size of 4 or 5, look at the critical values. It's actually not strong enough. That 0.85 correlation coefficient that we calculated is not greater than the ones in the table value if your sample size was 4 or 5. So it's actually not strong enough to indicate that there is a significant linear correlation. Pretty crazy, right? So keep that in mind. You really want to verify with the table of critical values to determine if there is in fact a significant linear correlation. Good, keep this in mind. This is very important. All right, let's turn the page. No worries, Sudhajini. Hopefully your internet will kind of level out pretty soon. Don't you hate that? It's the freaking worst. There is also another way to measure the strength of the linear relationship or to interpret R, the Pearson correlation coefficient. The value of R squared, this is important. Why don't we highlight it? The value of R squared is the proportion of the variation in Y that is explained by the linear relationship between X and Y. That's a mouthful, but I'll explain what that means. Looking at the previous example, we found R to be 0.61. So this means R squared or 0.61 squared is 0.3721. Now check out this interpretation. You may have to reread this a couple times. This means this value here, when you take that Pearson correlation coefficient and you square it, so R squared, this means that 37.21%, you see how they turn that into a percentage? This means that 37.21% of the variation is based on the independent variable. So essentially, the variation, 37.21% of the variation can be explained by your independent variable, your X variable. I'm just going to make a note here. Remember that your independent variable is your X variable, whatever value that takes on. That R squared is called the coefficient of determination, which we actually are going to use. We're always going to know what the Pearson correlation coefficient is, and we're going to talk about the coefficient of determination. What percentage of the variation, what percentage of this difference is credited to the independent variable? I think with examples and writing out the actual statement, it's going to make a lot more sense. So hold on to that idea for a moment and just consider the fact that this R squared, your coefficient of determination, will indicate how well that data fit a statistical model, okay? It lets us know that the variation is explained by the independent variable. Okay. So remember when we first started this class and we were talking about correlation versus causation, Starin had brought to our attention this example where, you know, if you're looking at summer data, you can find that the sales for ice cream rise pretty similarly to murder rates. So we're looking at both of those. And obviously we realize that one does not cause the other, but they are correlated. So let's take a look at this correlation. Ice cream sales, number of drowning incidents. So we're looking at a sample size of 30. Look at the Pearson correlation of ice cream sales and number of drowning incidents. Look at this number. Look at how closely correlated they are. That's pretty insane. When we look at the table of critical values where N is 30, you get a critical value of 0.361. Let me prove that to you. When N is 30, we have a critical value of 0.361. Since the absolute value of R is greater than the table value, and I'm going to go ahead and write that in there so that we can really feel comfortable with this idea, we can say that there's a significant linear relationship. If we look further and we calculate the coefficient of determination, we find that R squared is 0.964. You simply take R and you square it. Here is R. You take that value and you square it. What this is telling us is that 96.4% of drowning accidents, our Y value, right? Drowning accidents, our Y value, are explained by variation in ice cream sales. Whoa, that is an insane statement. What's happening here is we have a lurking variable, and actually Starin did indicate this when she described this scenario. She said summer, she said time of year, the heat, right? People are outside more, there's more activity, right? Families are outside more, they're getting more ice cream, people are outside more, and unfortunately that interaction is leading to more murder, right? People are just getting a little crazy. So we have something called a lurking variable. You'll also hear the word confounding variable. Either of those are referring to the same idea. So let me explain what this means. A lurking variable is a variable that is not included in a study, but has an effect on the variables in the study and makes it appear that those variables are related. This one's easy to see, right? We definitely know that ice cream does not cause murder. A lurking variable is related to both the explanatory X and response Y variable. Sometimes you might hear the word confounded. This means that any relationship that may exist between the two variables could be due to lurking variables or other variables not accounted for in this study. This is something really important that you should look at. Always consider, even if you do have your correlation coefficient, right? The data doesn't lie. It shows that there is a linear correlation. That's cool. It's extremely strong too, right? It's a very strong positive linear correlation. However, as the ones analyzing the data, we can clearly see, come on, there's got to be something else going on here. We know ice cream does not cause drowning. We know ice cream does not cause murder. Come on, let's be real about this. So there's definitely some sort of lurking variable. Cause and effect relationship. An association between an explanatory variable X and a response variable Y, even if it is very strong, is not by itself evidence that changes in X are actually causing changes in Y. This is exactly what we were just talking about. Correlation versus causation. A strong correlation does not necessarily imply causation. There may be underlying factors, okay? Be super careful in your interpretations. Let's go ahead and play around with identifying possible lurking variables. We'll go ahead and turn the page. Let's take a look at number 9. I would love for you to drive this conversation. So Abby, would you just read part A for everyone? And then I would love for all of you to just have a conversation about possible lurking variables. For part A, we have some ideas, but I'd love for you to verbalize that. So Abby Schuler, would you go ahead and read part A?
Ask which Abby. In the previous example of ice cream sales and numbers of drowning, identify possible lurking variables.
Awesome. What should I write? Go ahead and unmute yourself and just share.
Summer.
Summer. Tell me more.
There's no school for most people.
Lurking variables would be, you said summer, so would be time, the time of year. So summer, you said more, there's no school, so more students or more kids tend to be out, right? In the summer. There is no school. So kids are out, or adults, I should just say people. People are out buying more ice cream. Tell me more.
Would one be not everyone who drunk would have eaten an ice cream or had an ice cream?
Yes, I am definitely going to add that statement. There's no way of knowing if the ice cream that a person was eating happened to be in the water and then something went wrong and they drowned, right? How insane would that be? If it is summer, think about number of drownings. People are out more, so they're probably swimming more. So
There's probably, so there's I'm probably gonna take it to a whole new extreme. There may be more people like drinking, which causes more drownings.
Oh, yes. Alcohol is another possible lurking variable. Why is no one taking this into consideration? Alcohol consumption tends to increase.
And what about, well, this kind of goes under the same category, drugs too. More
Yes.
drug consumption.
Alcohol, drug consumption tends to increase, which may lead to more drownings. Or the purchase of more ice cream. Let's be real, right? Exactly. Which may lead to more drownings. Good. If you can fit in, you should write, there's no way of knowing whether or not that particular drowning incident was caused from eating ice cream in that moment, right? There's no way of actually knowing that unless you get the records, which show, oh, okay, this person was consuming ice cream and then things went totally awry and they ended up drowning. Good.
I have a question.
Yeah.
Well, it's not actually a question. It's kind of like a statement. So since we said in the summer, like there is no school, so kids are out buying more ice cream, and also they tend to scream. Well, if I like, would this be like the same thing as like, you know, because most of like teenagers, they take like risky behaviors, like especially in the summer, like
Yes.
they like to do crazy things. So like, I mean, would that also like
Yes,
apply to the scenario?
absolutely. That absolutely plays into this riskier behavior. I love this. You're totally right. That particular riskier behavior we see when school is out, we see over the summer more often than throughout the year. So yes, that totally can contribute to the number of drownings. You're absolutely correct. Very nice. I love this. So we can easily identify these lurking variables, these confounding variables. Let's do another one. Kelly, would you read part B for everyone? And then let's have a discussion.
In the 1970s, there was an oil shortage that convinced lawmakers to reduce speed limits in order to reduce gas usage. During that time, the number of highway deaths also decreased. Did the reduction in speed limits cause the number of deaths to decrease?
Oh, take yourselves off the mute. What do you think? This is interesting.
I think
People would
yes.
be driving less anyways, so there'd be less people on the road.
Right.
Interesting. Okay, so let me write something here. The oil, whoa, look at the and an O, E and O. Wow, my brain. The oil shortage resulted in fewer cars on the road. Yes, which seems like, okay, this is interesting. So there's fewer cars on the road. So you would expect that the number of highway deaths would decrease. Tell me more.
If there's less,
Oh yeah, go for it.
if there's less people on the road, then there's less people to get into accidents.
Very true. Fewer people or fewer cars means fewer accidents, right? Perfect.
Would
Speed is usually a factor when it comes to death and the car accident death.
That is true. We definitely.
I'll give you an example of a car accident that was involved in speed. Look at the wide receiver for the Raiders. I don't know if anyone follows
No, tell us.
that.
That shit was fucked. Sorry for my
I guess
language.
the wide receiver for the Raiders was driving 156 miles an hour
Breaking at
faster than a
100.
plane can take off. And it killed a pedestrian. He
Oh
hit a
my
pedestrian,
God.
killed him, and the car bursted up into flames.
Oh my God, that is so crazy. When did this happen?
Like last week.
Oh my God. What is
Yeah.
wrong with people? That is so insane. So yes, absolutely. So we're thinking that, you know, reduction in speed limits, maybe that did aid in the number of deaths to decrease. Yeah, for sure. But in that case, when you think about it, even if let's say the highway, and I know this is 1970s, but I mean, it's not like it's that long ago. Even if it were like 60 miles an hour and then you decrease it to 50, that wouldn't have an impact on someone who's driving like 140, 150 miles an hour, right? Like they're reckless no matter what. Did that
Right.
10-mile decrease really have an impact? And I'm wondering if, you know, maybe they're some other reasons that would kind of contribute to that particular scenario where there's a decrease in deaths. That's insane though. Why are people so freaking irresponsible?
Well, he was also intoxicated too, so.
Okay, there we go. Yay. Wow. Yikes.
I would say according to this problem, maybe if it has something to do with weather, like I know like New York snow, right? Storms, like I know people still drive crazy during that kind of weather. But,
oh, you mean that unfortunately the city has a handful of terrible drivers?
Well, Greece
Hey,
does
I'm one of
too.
them, but I accept that I'm one of those terrible drivers.
You're like, it is what it is.
Oh,
do
I
my
like
best.
yell at the people who drive like assholes, and I'm like,
Yeah.
shit, I'm one of those people.
Oh, that is so funny.
That is 100% true.
Yeah, I know. And it's funny because I'll go to other states and I'm like, these drivers are so much worse than New Yorkers. And I don't know, maybe we're just all really, really bad. I do want to point out, Abby commented on the fact that because there was a shortage of gas, the price would inevitably go up, right? So less people would be able to afford it. So maybe they're doing things like carpooling, right? That contributes to fewer cars on the road. So that's another thing that we may want to write. Also, Sudojini added that people might prefer to take public transportation to save on that oil, right? Both of those, perfection. Let's add that to our explanations here for possible lurking variables. So the oil shortage may have caused the price of gas to increase. Because of this, people may choose a public transportation method instead, or may carpool, right? Again, resulting in fewer cars on the highway. I would say that's probably a better indication as opposed to speed limits being decreased, right? Like really, when we think about it, if you're going from 60 miles an hour to 50 miles an hour, is that really causing the number of deaths to decrease? Let's think about what's actually happening here in the background. Good.
It definitely does not cause a decrease in deaths.
That difference in the speed limit, I would agree. I think it's too small of a change to actually have that kind of significant impact.
I mean, if it was from like 60 to like 40, like on 390 or something, then okay, maybe I would get it. But like, even
Also-
then, I would still be a little bit iffy.
Yeah. If that ever happened, I will never take the highway.
Yeah, same with me.
I will never. As it stands, people don't understand that the far left lane is your fast lane. So if they decrease that speed limit, I will never take the highway. You will see me whipping around the streets, just saying.
I take the fast lane all the time on 390, especially like the MCC or like same with 490. I'll take it anywhere.
Absolutely. So why do people drive so slow in that lane? It makes me crazy. Okay.
Fast and Furious in here, dang.
It's like I kind of have a little bit of road rage, just a tiny bit.
Don't we all?
Yeah,
Literally.
I
This
think-
one person, I was taking a left-hand turn, and this one person was behind me, and I guess he just didn't want to wait anymore because there was a ton of cars coming. So he just decided to go around me and almost get hit. So I proceeded to tailgate him and flip him off and follow him to where he was going and to yell at him.
Be careful doing that. Be
Well, we were
careful.
going to the same
Yeah,
place, which
I
made it even
know.
more awkward. So I was like,
Yeah.
oh, maybe you cut in front of me for no reason. But
I
yeah,
know.
yeah, I know. Smarter choices.
I know. I get it. I totally get it. I'm right there with you. And sometimes I'll just like look at the person as I'm driving past them, like, what is your problem? Learn how to drive, take a test.
Literally, how did you get your license?
Yeah, or tailgating. Lucy's commenting on the whole tailgating thing. That's when you put your hazards on. If somebody's tailgating, just put your hazards on. Chances are they'll back off because they'll be like, oh, something's going
Smart.
on with their car. So a little trick sometimes.
What about
I'm
people when they
definitely-
try to help you?
I am definitely one of the drivers that you guys are cursing at because I cannot to save my life. I don't know how I got my license.
Oh my God. Oh my God. That is so funny. That is so funny. Oh man, we gotta have you practice so you could build some confidence so you could whip around, you know, but in a really good way. Okay, enough. Let's look at part C. Athletes with the newest and most expensive running shoes tend to run faster. Does the price tag associated with the running shoes improve athletic performance? Comments.
I don't know. I mean, people tend to go for more things that are expensive
Uh-huh.
because they think it's better quality.
Okay.
So I guess I don't know.
Okay. like
Different materials, so it could be lighter,
It could be
lighter on your
lighter.
feet.
So more expensive could mean better quality, which could improve performance. Tell me more.
Professional athletes would make more money, so they would have
Mm.
more money to buy more expensive shoes, but they'd be faster anyways.
Okay. Tell me more. Yep. I love it. Keep going.
And then the more expensive, like the item is, it lasts longer. You know what I mean?
Oh, all right. So you're thinking the price tag is directly associated with the quality of the actual shoe itself. Okay.
I was gonna say that because I feel like the more expensive one would have, like, sometimes they have more comfort, and if you have comfort level, you can perform better.
I like that. That's totally true. You feel like you're bouncing around better, like you're moving better. And there's a difference between a really cheap shoe and a very expensive shoe.
Yeah, I've had that experience because I have like foot problems, and if I'm able to do like a 3 mile, it depends on the comfort of my shoe.
All right. So I have a question for all of you. What if I presented 2 pairs of sneakers and I said to you, the price tag on this one is $500. For that pair of sneakers, it's $500. And let's just say that you have a ton of cash, you're not worried about the cost, right? But let's just be reasonable about this. So I present to you the sneaker, it's $500, and I say, you gotta try these are amazing. And then I have another shoe that's right next to it that is, let's say, $250. It's half the cost. Are you always going to choose the $500 set of sneakers? Like,
No.
No.
tell me why. Tell me why. then.
Okay. I'm gonna, if personally, I try on my shoes before, and I do test them out. I am one of those people, but I don't do it I don't buy shoes, like $500 shoes, just like because
Just
I
because of the price tag.
yeah, and try to show off. I do it to make sure like they're comfortable for me.
Okay.
I don't care what anyone else thinks.
Okay.
And I know like people like judge on that kind of stuff, and people are jerks.
Yeah, that's true. That is true.
Personally, I'll give you an example. I bowl, so sometimes, all right, I'll give you an example. The shoes that I got were $50 bowling shoes.
Okay.
There are some shoes out there that are like $120, but they have switch grips, which I don't know if anyone does bowl or anything, but that means like this, like on the bottom of the shoes, you know how like there's a soft part like towards like your heel, and well, not towards your heel, towards like the ball of your foot and your toes and stuff.
Okay.
those can be like switched out, and those cost like way more. Those are like $220, $230. And I was like, I don't really need that.
Right.
I just need the one, and I can like use a brush and like use it that way and figure it out that way.
Okay, but pretend I'm the researcher and I'm telling you the cost of a running shoe, the higher it is, the better you perform.
Then maybe I'll consider it, but I would have to test it out for myself for a few seconds.
Okay, or you would say, you might be hesitant and you might say, I need to test out the shoe itself to determine if this is actually the truth. So
Right.
what if I came at all of you and I said exactly that? Pay more, you will improve your performance.
I tell him, listen, if you want to pay for my shoes, I'm all
See,
Okay.
I am one of those gullible people. I would probably believe them.
You're like, all right,
here
here it is, give me those shoes.
I know people that do marathons and stuff like that, and they said that doesn't matter the price of the shoe, as long as you switch out the shoe very often with a new one, because the minute the sole of the shoe like wears out, it's bad for your feet to walk in them or even run in them.
Yeah.
So they said it doesn't matter how expensive, as long as you have new shoes a lot, then you're good.
Yeah.
So $50 shoes is perfect.
It could be.
It's like fun, folks.
When I thought about this particular example, I thought about what it feels like, for instance, when you purchase a new set of workout gear. You ever buy a new set of workout gear or new shoes or a new something? Do you think about like how you feel when you put that on?
Oh, it feels
$1
amazing.
million bucks.
Exactly. Exactly. So if you're feeling like $1 million, you've got your new gear on, you're like, yes, I got Nike Air stuff. I feel like I'm just moving and grooving, like no big deal. Doesn't your performance kind of reflect that in the gym? It probably would. There's a pretty significant psychological effect from purchasing that new gear, right? You didn't buy it because it was $1,000. You bought it because it was the freshest of the fresh. And you're just like, this looks amazing. I want to put this on my body and I want to work out with this. And you have that psychological impact of like, ooh, I've got some really great gear. I look good. I feel good. I'm going to perform better. So there is a psychological effect because of that. Surujini.
I and I'm not, honestly, I'm not attacking anybody here, but I see that every time I go to my gym. Like I go to Metong, and there are people, they're the snotty people there who with their Lulus and everything, and they don't care. They just do what they have to do, and that's performance, regardless of how they do it. You can see that attitude, you can see everything. So it is true what you're saying, because I see it all the time.
Yes. I mean, people shouldn't be acting like douchebags because of it, but I like the person who's like, I'm able to buy these, these new kicks, or I'm able to buy this new outfit for myself and feel super fresh. And I just exude radiance and positivity and just like happiness and confidence and stuff like that. So yeah, I agree. Surujini, some people are going to be jerks about it, which I hate. It's such a bummer.
And you don't have to be like that. I mean, it does feel good. Like I can tell the difference between my stuff as well, but you don't have to be like that.
Really. You don't have to turn it into a negative. You can keep it a positive. The other thing I wanted to comment on is if you, for instance, are able to dish out $500 for a new pair of kicks, right? Let's just say you're able to be like, yeah, no big deal. I'm gonna pay this.
What kind of job do you have?
Right. What kind of job do you have? Which means, don't you think it's possible that if you can purchase those kinds of, workout gear or equipment, that you might also have access to things like a nutritionist, a fitness coach, a high-end gym, right? All of these things that would contribute to improved performance. If you're eating better, you perform better, right? If you have physical therapists who work with any issues you have, you recover better. So you perform better. all of these things play into this experience of athletic performance. So it's not just directly a price tag. Of
See,
course.
these are what like people like do that like a lot like with like housing and stuff. Like I don't know if you've ever know like if you've ever really noticed it, but we're redoing like our carpet inside of our house right now. And there's like some places that are saying like, oh, it's gonna cost this much and we'll get it all done for you in one day. Well, you kind of have to think, are they gonna damage like a bunch of stuff? Like in my room, I have like a bunch of stuff that they have to move out and then do the flooring and stuff. Do you really want like stuff to get damaged?
Right.
You know what I
Right.
mean? So you kind of have to think of stuff like that too. Like,
Yes.
yeah, the price might be better and you might get it done faster, but do you really want that
Right. You're
Like-
thinking quality versus
over
that
quantity?
Yes, exactly. You know, you have to weigh those options. You have to determine. You're absolutely correct. That goes with anything. You're absolutely correct. You know,
Right.
you think of CrossFitters and buying a new pair of lifters, you know, like, is the more expensive lifter really going to make that significant of a difference? You would, like you said,
Right.
you would want to test both of them out and determine if that truly is in fact the case. And sometimes you can get away with a less expensive lifting shoe, right?
In a longer time.
And a longer time. Yeah, you're absolutely correct. Absolutely. That was great. All right, let's write out a couple ideas here. You can write it however your heart's desire. I'm going to write, there's a psychological impact. Whoa, look at how I'm writing psychological. Guys, there's something wrong. My brain is not.
Just go make the coffee.
I know. Oh, you
Just
know what?
commit. Just commit at this point.
I'm so glad you're all like okay with this. You're like watching as my brain is like switching letters and all sorts of stuff. Let's try that again. I swear.
It's all right. I probably spelled it wrong too.
I swear I can spell. All right, the psychological impact. You look better. You feel better. You play better. You perform better, right? That's how it feels for me, at least. And I am a workout gear junkie. I'm so nervous about coming back to campus in this.
Girl, same.
Yeah, I have no like real clothes. I only have workout gear. And I can't wear that to work. That would
I just got a new job and I had to go shopping for work clothes because I don't have any.
Yes, I'm gonna have to do that right before the spring semester starts. So I'm
You
like,
might need to like take a part-time job at Dix's Sporting Goods or something.
seriously, I really should. Although, I mean, I get a lot of rewards all the time, which is nice. I'm going to say it is possible that the athletes have access to trainers, nutritionists, physical therapists, that contribute to the athlete's improved performance. That makes total sense to me. Good. Suji, that's so funny. You know, in high school, I was a creative writing major. I didn't even do anything with math other than I was a mathlete. Yes, I was on the math team. Can you picture what kind of a student I was? Hardcore nerd. Hardcore nerd. That's okay.
That's okay. Somebody's got to do it.
Yeah, exactly.
Go to high school.
I went to School of the Arts.
Yay.
Yeah, soda.
Since we were on the topic of lurking, I just had to tell you that. I just found it funny.
I like it. Like that cause and effect. You have a doctorate, so now you know how to spell. Like, I don't know. I've met a lot of doctors who cannot spell for the life of them. Excellent.
If they can't spell, you can't read it.
I know.
It's either
Oh,
both
yes. Or you're right, or the
It's-
handwritten like prescriptions.
That is so bad. And you're supposed to know what they're telling you to do.
When I got my
know.
wisdom teeth taken out, the guy wrote me some instructions and then he said he'd give me paper later. And I couldn't read his writing. So I'm like, and he had like a very thick accent because he was like a foreigner. And I was like, yo, I don't understand a single thing you're saying, but that's great. I'll do
Oh my God.
Luckily, I have my dad's a pharmacist, so like he pretty much helps me out with like the medications and stuff, and he knows like what they're saying and stuff. Like
That's so
with
funny.
like wisdom teeth, like they tried giving me oh my God, what is it? It was a narcotic, I think.
Oh, like Vicodin or
It was something like
Oxy.
that, and my dad was like, absolutely not. You're just gonna take ibuprofen
isn't
for a
that,
few
isn't
days.
that opioids?
Yeah.
No,
Yeah.
I was in a case study for my wisdom teeth, and they're like, "Oh, you're a perfect candidate." So what we're gonna do is I was literally like my first day there. They sat me down. They're like, "You look like you're perfect for this case study." I was like, "Okay, tell me more." I was like, "How much money am I getting?" They're like, "You're gonna get $125." I'm like, "Sold."
You're like, yes, please.
But it was interesting. They said that they were trying to determine whether the regular on-the-shelf medication, like ibuprofen, stuff like that, was better or worse than the opioids that they were giving you.
Wow.
So they gave me like this monitor thingy that I put on my wrist, and it looked like one of those house arrest things. I was crying. I posted it on my story. I was like,
like an ankle
house
bracelet
arrest
for your
around.
wrist. Oh my God.
Yeah, like track your your steps and your sleep and stuff like that.
Oh,
And then I had 2 bottles that were like smart bottles, like smart pill bottles. So I would have to like place them on a flat surface, and every single time I opened it, like it would like tell the people that I opened it. So like if I kept like taking pills out,
Oh, that is really interesting.
Yeah,
So
so-
monitoring how many times you would medicate for the pill.
Yeah, so you don't know, it's a double blind study, so they didn't tell me whether or not like I got the opioids or the regular stuff. So I was very careful about it because I was like, I don't want to get addicted or anything.
Yeah, for real, for sure. Good.
I would just keep taking the lid on and off.
Oh my gosh.
Then they'd be like, what are you doing? Why are you doing this?
Honestly, it was a really cool thing. Like it lit up when you took it off. Like I wanted
Wow.
to.
That is so funny. Oh my God. I love that. That's so awesome. Cool. You know what? You all are awesome. Do you want to just enjoy your Veterans Day starting like a little early? I know it's 9:54, but you know what?
Sure, this is my only class for the day.
I'm gonna let you guys go. Go have fun. Enjoy your
Actually,
day.
hi.